Hello everyone, my name is Saeed. I'm an aerospace engineering student at Carousel Long Beach, and today I'll be presenting Concorde, the first supersonic transport aircraft, or the first SST for short. Today we'll be talking about the development, some engineering aspects, and the failure of Concorde. We're also talking about the future of SSTs. So supersonic flight was a new technology, and countries were looking to be the first in the supersonic transport industry, such as America, Russia, and Europe. At first, such an aircraft was deemed impossible due to supersonic planes having very high takeoff speeds caused by short wings that decrease drag at supersonic speeds. This works great for military applications such as the F-104, but not so much for SSTs. Then came the delta wing design, with a report called flow separation in 3 dimensions, which basically changed the whole game overnight. The report stated that these type of wings create vortices on the upper surface at high angles of attack, which will increase lift, which is the perfect option for the SSTs. The only downside would be that it needed a high angle of attack when landing, but engineers could design around this issue. At this point, a big question surrounding SSTs was not if it would be possible, but if we could make money doing it. Therefore, the STAC Supersonic Transport Aircraft Committee was made to find a solution to this issue. They knew that there was no going around the increased fuel burn of supersonic aircraft, as the high lift-to-drag ratio of supersonic aircraft was much lower than subsonic designs, but they concluded that supersonic aircraft will be able to take more routes, thus fewer aircraft were needed, which will balance out the fuel issue. One competitor of the Concorde was the American Boeing 2707. It was a winner of the American SST contract, and instead of using a delta wing, it uses a swing wing design. Thus, the wing will swing depending on the speed of the aircraft. It was cancelled very early on in 1971, with only 2 prototypes being built due to the high cost and an unclear market and some environmental concerns, which we'll talk about later. Russia's answer to the SST was a Tupolev Tu-144, which was actually fully built and used for passengers, but rumors about this aircraft being rushed and built only as a political device were rampant. The 144 crashed at the 1973 Paris Air Show, further pushing these rumors. It crashed due to structural failure, and in this picture we can see a debris of the aircraft. Compared to the Concorde, this aircraft had lackluster engineering. It needed afterburners in order to sustain supersonic flight, which caused its operational costs to be much higher. The project was a failure in comparison to the Concorde, with only serving 103 flights filled with passengers. Compared to Concorde's almost 50,000 flights were extremely bad. So Concorde, being the only viable SST, it completed development in the mid-1969, being jointly designed by France and the UK. So now the country is focused on selling the aircraft to airliners across the world. Selling the Concorde has proven to be a huge challenge, as the plane has ballooned in cost, which was 6 times what was originally projected. The plane also created sonic booms, which limited its flights to only fly over oceans, such as the Atlantic. Then, as if Concorde was cursed, the 1973 oil crisis not only made airlines not want fueling planes, but especially not want the Concorde. And it has a very high gallon per passenger rating, 156 gallons per passenger. What's from this diagram, you can see is extremely high compared to the 747 and the 737 at its time. So as it turns out, the Concorde main competition wasn't any other SST, but actually the first ever jumbo jet, the Boeing 747. It was a much more attractive option, as it was much more efficient, cheaper, and was introduced earlier than the Concorde, 7 years earlier to be exact. The only downside was that it was slower. Out of the original 16 airliners that ordered the Concorde, only 2 fulfilled these orders: Air France and British Airways. And these are the same countries that developed the plane in the first place. Thus, the Concorde was a huge economic failure from the beginning, and it will only get much worse over time. Powering a Concorde was a major problem The use of turbofans was deemed impractical due to the increased drag force due to the larger area of the engine, as you can see here in this diagram. Thus, the turbojet was picked. More specifically, the Rolls-Royce Olympus 593 was picked to be used to power the Concorde, having proven himself on the Royal Vulcan, a military reconnaissance bomber aircraft that served the British military. Afterburners were only used during takeoffs and passing at transonic speeds, where drag was extremely high. Only 2 engines were used for taxiing, or just saving fuel costs. The engines were mounted behind the leading edge of the wing, would cause a unique issue to emerge, as it will intake the boundary layer of the wing, as seen in this simulation. This will decrease the efficiency of the engine considerably. Thus, engineers had to figure out a problem to this issue, which they did. Another problem was the noise. Unlike turbofans, turbojets were much louder, and majority of the noise come from the exhaust mixing with the static air outside, but nothing really could be done, as at this time there's no other options. Thus, complaints of the Concorde were rampant during its operation. Due to the delta wing design, pilots had a difficult time seeing a runway during takeoff and landing, as the plane needed a very high angle of attack, as you can see in this diagram, in order to produce the same amount of lift as normal traditional aircraft wings. Thus, engineers made a nose that could drop about 12.5 degrees, as you can see in this picture right here. Engineers also had to figure out a way to make this nose aerodynamic when it is in its top up position. So they implemented a visor that would not only make it aerodynamic but also protect the windscreen from extreme heats at high speeds. Due to flying extremely fast, it reached its max speed at Mach 2. The aircraft will experience very high temperatures due to air friction, with the surface of the aircraft reaching temperatures of around 250 degrees Fahrenheit. Engineers found that Humidurium, or R58, would work perfectly as a material for the aircraft, as its being an aluminum alloy allowed for reasonable cost and familiar construction compared to other airliners or aircraft. This allowed the aircraft to have a limit of Mach 2. The expansion of this material was also pretty unique, and at its peak it expanded around 12 inches. The aircraft was tested and approved for 45,000 flying hours, which was impressive, but less than half what the 747 could last. The Concorde had many issues, which led to its failure. One of this was its few flight routes that it had. It was forced to only fly over oceans due to its supersonic speed, creating sonic booms. If it does fly over land, it will be a transonic. Its fuel usage was also extremely high. In order to maintain a Mach 2 speed, it burned around 67,000 gallons per hour. The fuel crisis of the 70s also caused the price of Concorde to increase, decreasing demand. Some environmental concerns will also arise, as the Concorde produced 3 times as much CO2 and nitric oxide than a normal plane. It also flew around 60,000 feet, making the situation much worse. Compared to a normal airliner, the Concorde was 5 times worse in terms of climate impact. The Concorde only have a lifespan of 45,000 hours, means that by the early 2000s, many aircraft needed expensive maintenance. But considering the above issues, operators decided it was best to retire the aircraft soon rather than spend more money on already failure of design. The Air France Flight 4990 was the last straw to the Concorde story, as it crashed the 25th of July 2000, right after takeoff, killing all passengers. The crash was actually due to debris from another aircraft on a runway, which caused a major fuel leak leading to a fire. This caused public fear of the aircraft, thus pushing sales down on an already failing venture. And thus, in 2003, it landed for the last time. The future for SSTs is very slim, with only one company called Boom Supersonic producing or developing a new SST. The aircraft they're making is called the Overturn. They say that it will be capable of going Mach 1.7 and have a net zero carbon emission. The engines are also built in-house by the company. They call it the Symphony. It's a turbofan design, thus reducing the issues Concorde had with noise and fuel uses. This company being the only option for the future of SST, it's basically our only choice if we want to fly supersonic. So hopefully it goes well. So that was it for the presentation. Thank you for listening. Hopefully you learned more about Concorde and also SSTs. If you want to research more on your own, here are some sites that I use. And thank you.